So the final section of Unit 2 is to start talking about distance on the coordinate plane. So we're going to figure out how to do that. And we're going to start doing it with a graph, with a picture. And you're going to quickly realize that this has something to do with the Pythagorean theorem. So I'm going to start kind of with a real world example. Imagine that Evan was biking on a trail and a map of the trail is shown. So the trail that he is biking on is this red here, okay? And his brother timed his ride from points A to point B. What do the blue and red lines represent on the graph? So if we look at the blue lines, you're going to see that that kind of, if this was due north, it's kind of an east-west direction, a horizontal piece, and this would be like the north-south piece, which would be a vertical piece. So those two blue lines are creating a right angle there, and they represent the vertical distance and the horizontal distance between the points. So from here to here, you can see if you drag down, that would be the horizontal distance left to right between the points. And from here to here is the vertical distance between those 2 points. Now, what is this red? Well, that would represent the actual distance between the 2 points. That's the actual path. So the next question we're going to ask is, what type of triangle is formed by those lines? And can you see that right triangle? And the minute I see a right triangle, I'm going, interesting. I wonder if this has something to do with Pythagorean theorem. So how could you find the lengths AC and BC without counting the number of grids? Well, what they're saying is the first thing you could do, whoops, went the wrong way. The first thing you could do would be to count and go, well, this is 1, 2, 3, 4. So between this point and here, the horizontal distance he traveled was from here to here was 4. And they're asking you, how could you get that from these points? And if you look at the 7 and the 3, 7 minus that 3 would give you the 4. Now they want to know, what about the distance between the 2 points in a vertical distance? Like, how could you figure this out? Now, they said not to count, but let's just cheat for a minute. 1, 2, 3, 4, 5, and a little piece, right? It looks like it's a little beyond that. And if that would be 5, like in a half-ish. And if you look at the 2 y coordinates here, the 9.5 and the 4, and you take one minus the other, you get the 5.5. And remember down here, if you took the x minus the x, you got the 4. So we could subtract the x coordinates to get this horizontal distance, and we could subtract the y coordinates to get this vertical distance. So let me just get these uncovered for you. So if you subtract the x coordinates, you would get the 4 that we did. And if you subtract the y coordinates, you would get the 5.5. Remember that your coordinate points are always put alphabetical, so x always comes before y. So can we write an equation to find that diagonal using the Pythagorean theorem? So remember the a squared plus b squared equals c squared? Well, if we look back at the triangle, our 2 legs are the horizontal and the vertical distance. We just called this 4, so 4 squared, and we just called this 5.5 plus 5.5 squared is going to equal this red piece, which was his trail, squared. So 4 squared plus 5.5 squared equals c squared. And now we can pick up our calculator and square the 4 and get our 16. And square our 5.5, and if you do that in the calculator, you're going to see 30.25. Add that to the 16, we get 46.25, and take the square root. And he traveled about 6.8, and if I'm not mistaken, I don't think they gave us any units here, so it's just 6.8 units, whatever they are. So having said that, we can find the distance between 2 points who are kind of on the slant on the coordinate plane by kind of doing the technique we just did in creating a right triangle. So if we look at page 432 and we plot the points 3, 0 and 7, -5, we're looking for this distance, was just like the kid's path, right? So we're going to look and we're going to drop a vertical line down and we're going to drop horizontal line down, and we're going to create a right triangle. Now, these two sides that I've created, the two dotted lines here, are our legs of the right triangle. Now, yes, if we're on the coordinate plane, I can't just go 1, 2, 3, 4, 5. But if you were to take your x coordinates, your y coordinates and subtract them, that will give you that vertical distance. So 0 minus a -5, and if you change that, you would get 5. Or -5 minus 0 would give you -5, but again, distance is never negative. So either way, if we subtract the y coordinates, we're going to get that this is 5. Now, if I look here, so you see 1, 2, 3, 4, notice that if I subtract the x coordinate, 7 minus 3, I'm going to get that distance. And once I have the legs, here comes Mr. Pythagoras. We're going to take one of the legs squared plus the other leg squared equals the hypotenuse squared. A squared plus b squared equals c squared if you look over here. 4 squared is 16. Plus 25 is 41. They're kind of missing that line of work there that we like to see to make sure you can get your partial credit. And then remember that we take the square root of 41, and I allow you to go directly down here. And when you do that, you're going to see 6.4 in the calculator. Now we're talking about distance, and yes, there are two roots, a positive and a negative of the square root of 41. But when you're talking about distance, it's always positive. So these 2 points are about 6.4 units apart. So distance. To find the distance between 2 points on the coordinate plane, you graph the points, and then you draw a right triangle with C as the hypotenuse, and you use Pythagorean Theorem to solve it. So what I'm going to ask you to do right now is you're going to plot these 2 points on the piece of graph paper provided on page 432, and you're going to draw a right triangle. After you draw that right triangle, you're going to use Pythagorean Theorem to find the length of the hypotenuse. And the length of the hypotenuse will be the distance between those 2 points. So let's right now, first of all, can you go ahead, pause the video, and plot those 2 points? Okay, so let's see where those 2 points would go. Did you plot the first one, 1, 3? Did you put your point there? And then start at the origin, -2, and then up 1, 2, 3, 4. Okay, so the distance between these 2 points, that is the distance that I want to measure. And because it's on a slant, I can't count the blocks. So the next thing I'm going to do is create a right triangle. Now, some of you might be seeing it. Look at where I'm tracing, right? And some of you might be seeing it up here. It doesn't matter which right triangle you draw, top or bottom, but just draw one of them. So I'm going to drop this down until I'm at the same height of this point, and then I'm going to bring that horizontal, and there's my right triangle. So kind of a little lopsided there, but go with it, okay? So now that I have a right triangle, you can just count how many blocks are here, and that will be your A, and count how many blocks are here, that will be your B, and use Pythagorean Theorem to find the hypotenuse. I'm going to ask you to pause the video and solve that one, please. Okay, let's see how you did. I'm going to flip over here to the answer. Excuse me. So this would have been 1, and this would be 1, 2, 3. Now, just so you know, I could have gotten that 1 without having the picture. I could have taken 4 minus 3. So the difference in the y's would give me this number. Now the x was 1, 2, 3. If I subtract the x's, like -2 minus 1, that gives me -3. But remember, distance can't be negative, so it would be 3. So, there is another way besides counting to be able to get those numbers. But once they're there, here comes Mr. Pythagoras. We're going to take one of the legs and square it, plus the other leg squared, to equal the hypotenuse. A squared plus b squared equals c squared. And now I head to my calculator. 1 squared is 1, 3 squared is 9. That equals the hypotenuse squared. Add those together, equals 10. That equals the hypotenuse squared. So no, the answer is not 10. Remember that we need to take the square root of 10, and it's about 3.2 units. So don't forget to substitute square, add, and take the square root. And that's how we can find the distance between 2 points when we have a piece of graph paper, and we can do that and see the picture. Now, what we've just actually learned though, and this looks like a horrendously horrible formula until you just give me a chance here, is there is a way to do this without the picture. We can get the length of those legs by doing a subtraction, as I was mentioning all the way through. And so they've got something, and it's called the distance formula, and it looks crazy right here. But I want you to come down here and remember that in Pythagorean Theorem, you take a squared plus b squared, and then you take the square root to get the length of the hypotenuse. So this is just a version of this. But what is the a? Well, what you're going to do is you're going to take 2 points and you're going to subtract the x coordinates, x minus x, and then you're going to square it. You're going to subtract the y coordinates and you're going to square it. You're going to add it together and take the square root. So in other words, the a, the length of the leg, will be x minus x. And you're wondering, like, what's this little 2 and this little 1? That's just telling you the x from one point minus the x from the other point. They're calling it 0.2 and 0.1. And it really doesn't matter the order. And, why did they put 2 first? I don't know. It really doesn't matter. Because if you go one way, you'll get a positive. If you go the other way, you'll get a negative. And when you square it, it's always positive. So basically what you're going to do is you're going to take your x coordinates, the numbers that are in the first place of the points, and you're going to subtract them, write it down, and I like to catch it in parentheses. Put it to the square. Then you're going to subtract the y's. That's the second numbers in the points. You're going to write that down and put it in parentheses squared. You're going to square the difference of the x's, write it down. You're going to square the difference of the y's, write it down. You're going to add those together and take the square root. A squared plus b squared, take the square root, will give you the length of the hypotenuse. So let's do one. It makes a lot more sense once we get busy. So again, here is the distance formula. It's what I just talked about. They're taking the Pythagorean theorem and kind of turning it into the distance formula. On the last page, I kind of talked all the way through that. But you can find that on page 433 of your book. All right, so here's going to be the problem. No graph paper, guys. So you've got it 0.5 comma negative 4, x coordinate, y coordinate. Another point, negative 3, negative 2, x coordinate, y coordinate. So you're going to take the x coordinate, and it doesn't matter which one you start with. Matter of fact, I added a line to the book to show you what if you had started the other way. So they start right here, and they take that negative 3, so where they wrote it down, subtracting the 5. Now, the number one mistake is to grab kind of an x and a y. So what I recommend doing is if you kind of circle, like you could circle your y's or something. So just something so that you can see that they go together and you don't accidentally grab one or the other. So now if you come here and look, so they took that 5, or excuse me, they took the negative 3, wrote it down, minus the 5. So they, subtract the 2 guys that aren't circled. Now, I did it the other way as well. I said, what if you went 5 minus a negative 3? Okay, so I did it in both directions. So x minus x, square it, plus y minus y, square it. Negative 3. Now, you can pick up your calculator, but what I'd like you to do is think your answer first, check it in the calculator, so we make sure that you are continuing to practice negatives. So a negative 3 minus 5 is a negative 8. And don't forget, catch it in the gloves. And we're going to square that. Negative 2 minus negative 4. That would be a same change, by the way. That is going to give you a positive 2. If it's positive, you really don't have to catch it in the parentheses. So negative 2 minus a negative 4 is the same thing as negative 2 plus 4, which is a positive 2. So I want you to put this in the calculator after you think it. So put negative 2 minus negative 4, hit equals, and you'll see 2 in the calculator. And then you're going to raise it to the second power. That's where we're going next. So negative 3 minus negative 5 is negative 8. We're going to square it. Plus negative 2 minus negative 4 is positive 2, and we're going to square it. I'll come back to this in a second. So when I put this in the calculator, make sure you put the parentheses in. After you square these, there should never be a negative, because when you raise something to the second power, it will never be negative. Negative 8 times negative 8, a bad thing happening to a bad person, is going to give you a good thing. 64, 8 to the second, or negative 8 to the second will give you 64. And 2 to the second will give you 4. Add them together, 68, take the square root. I don't know why your book keeps having to remind you there's a negative root. When we're talking about distance, you're only going to talk about the positive. Now, I want to go back and just remind you that, they started the subtraction with a negative 3. What if we went the other way? What if I had started with the 5 minus a negative 3? And 5 minus a negative 3, think what the answer is. Check it in the calculator, and you're going to see a positive 8. But when you take a positive 8 and square it, you're going to get the 64. 8 times 8. Now, if you start with the negative 4 for the y's, so negative 4 minus the other y, which is negative 2. And again, think this and then check it in the calculator. Negative 4, and this becomes plus 2, would be negative 2. And if you raise negative 2 to the second power, you're going to get 4. So the order, who you start with, doesn't matter. You'd get the same answer. So what we're going to do now is we're going to take this to the real world. We're going to do another one together. We're going to add one step on the end, and then it will be kind of your chance to give it a go. So, on the map, they're going to do this one both ways. So they're going to do it using the method 1 by drawing the triangle, and they're going to use the distance formula on the second one. Okay, so method 1 is what we started with today. And basically, we are going to have these 2 points. Here they are. And we're going to use the Pythagorean Theorem. So it's a little bit hard to count blocks when they're not whole blocks. And that's why that whole distance formula really helps. Okay, so you have to find the distance this way, and you have to find the distance that way. Those will be your legs, and we're going to use the Pythagorean Theorem. So on a map, each unit, each block here represents 45 miles. That's called a key on a map. West Point, New York, is located at 1.5, 2. So if you kind of look, they've got the origin kind of weirdly placed where my cursor is right now at 0, 0. So you're going to go 1.5 and then up 2. So that's where they got that. I'm going to go back to that weird position origin right here. And Annapolis, Maryland is located at negative 1.5 to the left and down 1.5, and there's Annapolis. And they want to know the difference between West Point and Annapolis. So we need to make a right triangle, which is what you're seeing here. And if you kind of count the blocks, you're going to see that the change in y, the difference in your y would be 1, 2, 3.5. That's the 3.5 right here. And your change in x is going to be, you've got kind of a half block here. So that's 1.5. And then we go another half block would be 2. And then another whole block is 3. And that's really hard to see, but it's basically 1 and 2 and 3. 1, 2, and 3. So we're going to take a squared plus b squared equals c squared. This would equal 9. And then if we take 3.5 raised to the second, that would be 12.25. And again, your book's kind of failing at putting that next line of work, which would read 9 plus 12.25 equals c squared. And then we would add, and we would get 21.25. And then to undo the squaring, we take the square root, and in the calculator, we would see 4.6. And again, it has to be positive. So initially, on the map, this would be 4.6 blocks on the map. But we want to know, what is the actual distance if you're driving in a car? And you got to go up here and realize that every block is 45 miles. So if I had one block, it would be 45 miles. But I don't have one block. I have, 4.6. So how am I going to take that next step? Since each map unit is 45 miles, I'm going to take the 4.6 blocks, units, and multiply it by the 45. And the distance from West Point in New York to Annapolis, Maryland is about 207 miles. That same exact problem, this time, we're going to do it using that idea of subtracting the x's, square it, subtracting the y's, square it, and take the square root. We're going to use the distance formula. And, the mess of trying to look and count over here, you're going to find that this might be the easier method. So we're going to take our x coordinates, and I'm going to remind you again that if you find yourself almost kind of like messing up and who's who, you can just come in and circle either the x's or the y's. So in this case, if we're going to circle the x's, right, there's the x, he's the first one, and there's the other x. And when you do that, the ones that are circled go together, and the ones that aren't go together, okay? So we're going to start, and we're going to pick our x coordinate, and they decided to start with this one, which is fine. So this x minus the other x. So negative 1.5 minus 1.5, and then we're going to square that. Plus, now we're going to do the y's. Don't look at the circles. Here's a y, negative 1.5, and subtract the other y. And that's what they wrote down, and then we're going to square it. A squared plus b squared would equal c squared. And if we take the square root, we will get that hypotenuse distance. Now be careful right here. I can't tell you how many kids would say this is 0. Negative 1.5 minus 1.5, do that in the calculator. You're not going to see 0. It's negative 3. So you would keep this guy the same. You change him to a plus, and this would be negative 1.5. So negative 1.5 plus negative 1.5 is going to give you negative 3. Catch him in the gloves, guys. Make sure he's in the parentheses, and we're going to square him. Negative 1.5 right here minus the other y. And again, be careful, negative 1.5 plus a negative 2, put it in the calculator, is actually negative 3.5. Catch them in the gloves because we're going to square them. And now head to the calculator. Negative 3 in parentheses squared is going to give you 9. A negative 3 times a negative 3 is a positive 9. Bad thing happening to a bad person is a good thing. Same thing kind of over here, 3.5. Negative 3.5 squared is going to give you a positive 12.25. You're going to add these and take the square root, and we are right back to where we were a second ago. And we're going to take that 4.6 and multiply it by the 45 miles, and the distance, once again, is 207 miles. You're basically doing the same math, but one of them requires you to kind of be counting and looking at the graph, and the other one, you just subtract the x's, square it, subtract the y's, square it, add those together, take the square root, and you'll get the distance. A squared plus b squared equals c squared, and you take the square root at the end. So here is your chance. So the first thing that I want you to do is to simply find the distance. Just what is the distance between these 2 points? Now again, I'm going to help you a little bit by going over and grabbing my circle, and I'm going to circle the 2 x coordinates. So when you go to do your subtraction, make sure you're subtracting the 2 things that are in the circles, square it. Subtract the 2 things that are outside the circles, square it. You're going to add those together and take the square root. And then I want you to play the video, and then we'll talk about the next one. Okay, let's see how you did. So x minus x, 2.5 minus 1.5, and I'm going to square it. And 3.5 minus 4.5, and I'm going to square it. Pick up my calculator. 2.5 minus 1.5 is 1. And 3.5 minus 4.5 is negative 1. Catch it in the gloves. 1 squared is 1. And negative 1 squared is 1. I'm going to add those together, a squared plus b squared. That gives me 2. And I'm going to take the square root to get the hypotenuse. Now, the square root of 2 is an irrational number, and it's going to be about 1.4. but I want to know what the distance is in miles. This is blocks on a graph. So each map unit, each one of these is 0.1 mile. Then how far would it be if I have 1.4? So now I want you to take this and using this, change it to miles. Come back when you've done it. Okay, so what do? You basically take your 1.5 times your 0.1, you multiply the number of blocks times the number of blocks per mile, and you're going to see about 0.14. And don't forget to put your units in at the end, which would be miles. So today we took the Pythagorean theorem and we applied it to finding distances. And this gets used a lot in the real world. I know we were just kind of using maps, but that idea of a right triangle, being able to find a distance where we can't measure it directly. Imagine that the distance is across a lake or across a canyon, but you can measure the two legs, but you can't measure the other distance. Well, you can use the Pythagorean theorem to get that distance. So we did it on a map by creating the right triangle and actually counting the legs and doing it that way. And we also realized that we don't need the map, and we can take the x coordinates, subtract them, the y coordinates, subtract them, square that difference, a squared plus b squared, add it together, take the square root, and we will find the distance in units. And then sometimes they'll give us kind of a conversion here where we can change it to miles or feet. So today it's all about finding distance, guys. So give it a try. Hope you have a good day. We'll see you.